Good morning, good afternoon, and good evening. It's certainly a real pleasure to welcome you today to this exciting event. Over a year ago, we launched this University Leadership Series as an opportunity for our global community and our international students to dialogue with university leaders on some of the world's most pressing issues. To date, we've had several vibrant discussions featuring the president of the university and on a wide range of topics that range from arts to health policy. And today we will just be discussing an urgent and important topic on climate change and the transition to net zero. It's my pleasure to turn this over to Safwan Masri, our Executive Vice President for Global Centers and Global Development, to introduce the event and to get us started today. Welcome.
Thank you, Julie. Thank you. I'm pleased to be here today with you and with our colleagues, Mary Boyce and Costis Maglaras, deans, respectively, of Columbia's Fu School of Engineering and Applied Science and Columbia Business School. Next month, Dr. Boyce will become provost of the university, the first woman, and I believe the first engineer to hold that position. Congratulations, Mary. And thank you, everyone, for being here as we join in today's seminar addressing climate change and the transition to net zero, and in particular, the role our university has taken on in addressing these complex global problems. When we convened to give structure to today's discussion, we ended up with a list that ran for more than 3 pages of just the questions we wanted to address. Obviously, we will be able to tackle only a tiny fraction of what climate change encompasses and our attendant responses. We are witness in real time to the effects of our warming planet, increasingly severe coastal flooding, withering droughts, devastating wildfires, unbounded by season, and storms of the century arriving every other year, all of which have enormous impact on food supplies, housing, transit, and migration patterns. Today, we will be talking primarily about ameliorative measures devised from policy frameworks, business modeling, and developments in engineering. But we must acknowledge that we are actually talking about survival for ourselves and for the planet, where once we focused on sustainable practices, we now inquire about planning, design, and resilience, because this issue is no longer one we can consign to future generations. It has collapsed into one that is immediate. In the first 6 months of 2020 alone, nearly 10 million people were forcibly displaced by climate-related disasters. What we do today matters. Perhaps it matters almost more than is tolerable for the human mind. What kind of psychological sophistication can we employ to motivate action from paralysis in facing the looming ecological disaster? This moment demands massive changes in both lifestyles and in perceptions of how the universe works. The notion of our struggle with time and how we are to use it now without leaving the future in shambles at our feet brings to mind one of the most influential authors of the 20th century, Marcel Proust, who seems to be having a moment these past few months, appearing on people's quarantine reading lists and in recent magazine essays. Although our concern today is not a pandemic, it shares a common theme with climate change, the threat of imminent collapse, death, and the potential for extinction. Proust's 7-volume novel, À la recherche du temps perdu, translated variously as Remembrance of Things Past or In Search of Lost Time, comforts in its length, extending any ending impossibility far in the future. But the book is not about staving off death or even confronting mortality. It interrogates time and the way we use it, and it asks us to reassess our lives, not in the big hinge moments, but in all the little ones. Time, in Proust's telling, behaves like a polymer, shifting, changing shape, and challenging concepts of linear behavior, which lets us live in the past while evoking the sense that the chance for new beginnings remains. It isn't, Proust might say, too late. We can recover missed opportunities and get it right this time. To do so, we must move beyond the psychological to the practical, marshalling resources, disciplines, institutions, and governments in much the same way we have done with COVID-19. Columbia University is already there, helping to get it right. We are engaged in incredible work to help the world change the narrative on climate change and to help slow things down, to stave off one ending and create a new future. Today, with deans of two distinct schools within the university, we are going to highlight the collaborative, pan-disciplinary work that is bringing people together in exciting, creative, and hopeful ways. This is the work that will occupy the next few generations in schools, in the workplace, and at home. Costis Maglaras is Dean and the David and Lynn Silfen Professor of Business at Columbia Business School. He is an expert in quantitative finance and data analytics and the recipient of awards for teaching excellence and innovation. In 1999, Costis received the Inform's Nicholson Prize, and in 2008, the Inform's Revenue Management and Pricing Section Award for Best Research Paper. Dean Maglaras has also chaired the business school's Decision, Risk, and Operations Division, where I had the pleasure of being his faculty colleague for more than 10 years. Costis serves frequently as a consultant to industry, primarily in areas of quantitative finance and electronic trading. I am pleased to call him a friend and professional and academic kin. Not only have we worked alongside one another, we both received our PhD in engineering from Stanford. Mary Boyce is another kindred spirit, an engineer who is Dean and the Morris A. and Alma Shapiro Professor at the Fu Foundation School of Engineering and Applied Science. As Dean and soon as Provost, she is a pioneer, the first woman to hold either of these positions in Columbia's 266-year history. Mary's research focuses on nonlinear mechanics of soft materials. She has been widely recognized for her scholarly achievements, including election as a fellow of the American Society of Mechanical Engineers, the American Academy of Arts and Sciences, and the National Academy of Engineering. Most recently, Dean Boyce has been recognized with the American Society of Mechanical Engineers 2020 Timochenko Medal, considered the highest scholarly recognition in the field of applied mechanics. Dean Boyce's transformative impact at SEAS, the School of Engineering and Applied Science, has included an inspiring new vision for the school, Columbia Engineering for Humanity. Dean Boyce earned her PhD degree in mechanical engineering from MIT, where she became a faculty member and department chair before coming to Columbia. Mary, Costis, welcome to you both. Let me begin by asking a basic foundational question. Climate change may not be obvious to everyone as a course of study within a business or engineering school. How and why have you guided your respective schools to tackle climate change? Mary, if I may, I'll start with you.
So thank you, Safwan, and welcome everyone. Thank you for joining us this morning. So I think most engineers would say climate change is a rather natural thing for us to be exploring and confronting and bringing the solutions to. When we look at Columbia Engineering, thank you for mentioning that we have a guiding vision, Engineering for Humanity. And this is really built on our aspirations to bring an engineering impact on human lives around the world, and really noting that our history at Columbia Engineering has been to do so for our over 150-year history. So bringing our impact on sustainability, on health, on security, on how we connect with one another, and on creativity. So we refer to this as engineering for a sustainable humanity, a healthy humanity, a connected humanity, a secure humanity, and a creative humanity. So you can see, even embedded in our guiding vision, we have climate change, right? We may refer to this as sustainability and as health and as security. So these things are all interconnected to one another. And when we look at all the different work, our research and our education programs are all somehow also focused in different ways on confronting climate change, whether we're looking at how decarbonization, And I know we're going to get into these details, so because I can go on this topic, but all the different elements there on clean energy, clean water, clean air, clean materials processing, clean chemicals processing. So what are we doing in those areas? These are areas that we really have been focused on over the years and have really accelerated over the last several years on how can we bring that impact and how can we today accelerate that impact. So the introduction of the climate school here at Columbia is really going to bring us all together to accelerate our impact. So there are so many different areas. We work on the climate modeling and prediction, and how can that guide where we put our efforts. And then also the very foundational areas of advanced materials and devices, of computation, of artificial intelligence. We're seeing such rapid developments in all these areas. So this has been a focus in engineering. And you know, some of our faculty like to say, we're ready, right? That when we focus on those foundational elements, it makes us ready, prepared to really tackle the big challenges of the day. So Safwan, I'm challenging you that I think engineers think it's natural that we're focused on climate change, not unusual, that this is something we want to confront, we want to have our impact. And today, especially at Columbia, we can do that with our engagements across the university. And that's also one of the major purposes of introducing the climate school. So you can see Safwan's trying to get me to quiet down. So I'm going to pass the baton and I'll get into more detail as we go on.
Thank you, Mary. And I'm convinced, as an engineer, I am convinced of the role of engineering in tackling climate change. Costis, talk to us about the role of climate change at the business school. And then we want to go back to what Mary mentioned in terms of the climate school and the university-wide initiatives that bring together the business school and the engineering school. So Costis, over to you, please.
Terrific. Thank you, Safwan. Thank you all for joining us today. Thank you, Mary. So just to step back, I mean, climate change is an incredible challenge that we've been sort of starting to discuss. And I see 5 key elements in thinking about that problem over the next several decades. Climate science is one, climate modeling that Mary was mentioning, technology, engineering, the development of solutions across the spectrum of problems or issues that contribute to greenhouse gas emissions. Business, economics, financing, incentives, it's a key way of taking all of these solutions and actually implementing them at scale. Policy will be crucially important in doing that. And finally, I want to add something that has to do about psychology, information, and what people think, perceive about what is going on, because I believe that that's going to be a crucial piece. So in thinking about all of that, we believe at the business school, like Mary was saying, that this is just core material for us. This is sort of one of the most important changes, challenges, and efforts that is going to transform what's happening in businesses across the world, across industries. Either you're a solution provider, or you're thinking about your own transition, or you're an asset manager, or you're managing a supply chain, or you're building a manufacturing plant, or you're a consumer, or you're marketing consumer products. Whatever our students end up doing will be affected by exactly what we're discussing today. As a result, it's an imperative for the school to be focusing, we have been focusing on both curriculum and research in that topic. Curriculum to support our students and alumni, research, because I think there is a lot of work to be done in how to actually bring some of these brilliant innovations that are happening across the university and primarily the School of Engineering and the hard sciences here. How do we push them out to the world, and how do we implement them at scale? And I want to make a very quick observation that when we electrified this country, that's a complex problem, right? It's complex, it's expensive, it's time consuming. It took us about 7 decades. Okay, and it hasn't really been completed across the world. We have known about this for about 140 years now. we still haven't electrified the planet. So we want to solve a problem globally for climate change in the span of 3, 4, 5 decades. So you can understand that this is a major challenge. It's going to be a complex challenge, and we will need to be resourceful and collaborative. And jumping back to the collaboration, I think it's absolutely crucial. The same way that digital transformation that has been sort of driving society in the last, several decades and has brought the School of Engineering and the business school much closer. Our efforts for climate change are going to sort of bring us closer yet. But I believe it needs to bring engineering, the business school, SIPA, the new climate school, because all of these components, including our colleagues in psychology, sociology, etc., all of these components are crucial in actually advancing change quickly. So I think that's going to be the name of the game, and we're trying. The university, as you know, has been a leader for more than half a century in that area, and we hope to be the leader in that area for the next half a century.
Well, Costis, thank you for, sorry, Safwan.
No, go ahead, Julie.
Okay, no, thank you for setting up our sort of next question, which was really to talk a little bit more about this sort of interdisciplinary or pan-disciplinary collaboration between the business school, the School of Engineering and Applied Science, the climate school, and the broader university effort, and maybe give us some specifics about some of the opportunities you're excited about between your schools and across the school and with the new climate school.
And maybe even, in addition to the new climate school, the Data Science Institute, which sits in engineering, Columbia World Projects. President Bollinger has recently made an announcement of Columbia's climate sustainability plan for 2030. So how do all of these things come together, and maybe starting with the collaborations between your two schools? Mary, do you want to take that first? Mary, you need to unmute.
Sorry about that. Yeah, so we can look at lots of different things that are going on across the university and how we intersect with one another. So when we think about, let me first bring up the Data Science Institute and some of the collaborations that have been really helped propel by these different interdisciplinary institutes. So for example, when we look at climate modeling, in climate modeling, that has really been foundationally developed from our physics and chemistry-based modeling. Okay, so what we call computational science and computational engineering science modeling. And how do we really predict the climate around the world? Obviously, it's a global problem. And now what we're seeing is that our climate modelers are engaging with our artificial intelligence computer scientists, right? So how do you bring artificial intelligence capabilities together with the physics-based modeling? And then with that information, how do we use that to help guide where we drive solutions? Okay, and also how do we drive use that as decision making in these business decisions, right? So we're starting to see how these will start to converge. So all of these different areas have now become intertwined, also intertwined with policy, how, collaborations together with the policy school. So as we see all of these pieces start to knit together, right? It creates more and more collaborations from one school to another, right? And our climate school, which of course is only just now in a nascent stage, is really bringing us together in a more impactful way, right? How will engineering solutions drive business solutions? How will these guide logistics chains? How will these guide companies when they're thinking about ESG, right? Environment, social and governance aspects of their companies. So all of these elements are now coming together in a really knitted way. So we also see that we need to understand how do we more rapidly accelerate the new ideas, the new solutions, the new technologies that are coming out of engineering schools, for example, such as ours, into more rapidly into new businesses, right? So our collaborations across engineering and the business school, together with, of course, our Columbia Technology Ventures, also will help us accelerate our work out into the real world as we start to really also develop the right kinds of business models to make that happen. So there's many different ways that we're knitting these elements together. And we're also doing that through new degree programs. So for example, we have, well, I'm going to give an announcement of one that's not yet approved by New York State. It's in the process. So Julie will have to forgive me for long, but Costis and I are really excited about a new degree program where we have are introducing a Master of Science in Engineering combined with an MBA, right? So this will be, you know, it's a year away from launching, but within this program, a student getting a Master of Science in Engineering can focus on sustainability areas, and then also at the same time knit that together with their MBA. So we're seeing new ways that we can really put these programs together to accelerate the impact our students will be able to have through their education programs. Costis?
That's good. I'm happy you announced our
And for everybody in the audience to know, Julie Kornfeld is Vice Provost for Academic Programs. So she sits at the cusp of schools such as yours and dealing with the New York bureaucracy to get this through. So Julie, I think this is a step towards that.
Coming attraction.
Step towards that. Not yet here. Not yet here. But it's sort of emblematic of where we're going to really serve our students and our future.
Yeah, I'll make two quick comments. I think Mary's description is exactly right. The problem, the challenge that we have requires interdisciplinary solutions. It's complex. Even the engineering or the technology that is needed when we come up with some kind of innovation that can, let's say, solve one specific aspect of the climate change puzzle, sort of producing that, sort of distributing out to the world at scale and at cost, at a good cost, low cost, is still a pending problem if we're going to do it quickly, in a timely manner, and in a way that the population, our population, but also international population, will be able to absorb. So in some sense, and in an equitable way, which is another thing that we could possibly touch upon later on. So working together and working together quickly so that ideas can actually put to test, try to commercialize, try to push them forward. Policy colleagues are pushing for transformative changes in both regulatory frameworks, but also the understanding of how governments work together. All of these things need to be working in sort of tight choreography in order to do something. I want to give an example that comes from solar energy, another area that our engineering colleagues have done wonder over the last decade or two. But the cost of producing solar energy has gone down by 100-fold in the last 20 years and by about 10-fold in the last 10 years. Okay, and now it's actually cheap. Now, why did that happen? Well, it happened because we had engineering breakthroughs, but it also happened because there were incentives put down by governments in Europe and then in the US, Germany in particular in Europe, and then in the US, to sort of support the installation of these things. And then once these incentives were in place, corporations, in addition to academic labs, R&D in corporations went down to work very aggressively to build both good, inexpensive, scalable, efficient solutions. And 20 years into it, we have brought down the cost by a factor of 100. So we need to do that in other areas as well, because we need to be able to absorb the cost of rolling this out globally. Anyways, I'll stop at that and then we'll continue.
Yes.
So, Costis, I mean, let's pick up on this because one of the areas, Mary, you wanted to.
Yeah, I was just going to say, I think this is really illustrating the fact of how we really need to integrate policy and business with the engineering and science breakthroughs. That these can't happen in isolation. The solar is a great example, and also we should remind everyone that fossil fuels are actually, there's an incentive. They're subsidized right now, right? So but we're not subsidizing solar and green areas, but other parts of the world have, and that really then accelerated our ability to take the breakthroughs in solar energy and bring them into a larger scale implementation. So we have many areas like that are waiting to happen, and the breakthroughs are starting to happen. Of course, we need a lot more work in the basic sciences and engineering to continue to pursue those breakthroughs and take them from a breakthrough idea to something that is more translatable into a real product and a real solution.
So let's talk. I mean, let's build on this and let's talk about sort of government and policy and business and the role of business. And since you brought up policy, Mary, I mean, what kind of political leadership is needed? What kind of policies need to be adopted? What can a president like Joe Biden, who very clearly is committed to tackling climate change, unlike his predecessor who denied climate change. What kind of policies should we expect to come out of the White House, of Washington? What advice are you and maybe Costis and others giving the current administration? And maybe as we talk about this, let's talk about the global space. So it's not only policies within the United States, but how can we marshal resources around the world? What can we expect of key global players such as China in dealing with this? Because I mean, I think we hear you loud and clear. There's all the stuff that happens at the university and at research institutes, but without it being translated into policies at the government level, without it being translated into business practices, then there's a limit to how far we can go.
So let me first comment on the new administration, the Biden-Harris administration's potential impact on science and engineering breakthroughs. Okay, so we see a huge commitment coming from them to really support and to really expand dramatically the support for science and engineering research across the United States. This is something that's an economic imperative for us to remain a leader in the world, and we do see this coming, and we see many of our senators and Congress people really helping support pushing these new policies and these new levels of support forward in order for the U.S. to really remain in a leadership position in driving those new ideas coming out from universities. And we have to recognize also that many of the solutions that are needed for clean energy, for decarbonizing our manufacturing processes, for providing clean water, I mean, we can go on and on, that we still need a lot of work to make those happen. And those ideas come out of universities in large part. So this sense that the Biden-Harris administration is looking to really accelerate what's coming out from universities, and not just in the near term, but in the long term, understanding we need these fundamental developments and we need to be translating them into real world impact, and also simultaneously putting us back, putting us, by us I mean the United States, back in a leadership position around the world of recognizing that climate change is a global problem. And the U.S. needs to be leading in this in the developments of the solutions, and also in the policies, not just the policies across the U.S. that are going to, electrify cars and buildings. Not to go back to the electrification, but Costis talked about the electrification. We have a lot more electrification that needs to happen in the U.S., but in a different way than Costis was talking about, just the electrification of so many of our current systems, which can be translated into greener systems. But in any event, there's lots to happen nationally, but also setting the stage globally. We need to be in that conversation.
So, Mary, can you, when you talk about all of this, I mean, obviously issues of intellectual property come up.
Yes.
Sort of also reinforcing entrepreneurial activity and encouraging startups. So, how do you deal with that? I mean, how are you approaching this? What kind of challenges?
Yeah, so we have a lot of intellectual property coming out of Colombia, that we have different ways within Colombia that we are working to accelerate that IP into startup companies and/or licensing to larger companies, which is also, of course, still a great and fast avenue for translating developments into real world impact. So in the startup world, we have new ways of really licensing our technology to startups to enable our startups to get off the ground in a faster way. We need more support for this, of course, and we are pursuing additional ways to support those startups that are require a physical, chemical, wet lab type of support in order to really be translatable into a product. So we have new ways that we are pursuing to further support those startups so that they're not slowed down. We've referred to those often as tough tech. Okay, when we have areas in energy or materials processing or manufacturing, or new materials or new devices, they require a lot more support to really get going. And we'll be introducing new mechanisms in order to support those companies coming out. We also have a network which just for so many of our students and alumni who are in the audience here, we have a network, or we have an incredible Columbia Technology Ventures with a network of what we call lab to market accelerators, of different ways that we provide support to faculty, students, researchers to be translating that work to get out into the real world. And also through partnerships with the government. So with NYSERDA, with federal support, there's NSF, I-Corps support. So there's different ways that we're putting together the support to accelerate our research. But the government needs to come in at the state level, even the city level, the state level, the federal level, to really further support how we accelerate our work out of the lab into the marketplace.
Safwan, let me jump in. I want to add two quick footnotes to what Mary was saying. The first about the Biden-Harris administration. The push that they're doing towards green infrastructure is strategically important. It's strategically important because it starts putting us back into being the solution leader in the fight against climate change. It's a way of creating jobs, and they keep saying that, but that's crucially important for this country and for the world. And it will create tremendous economic opportunity for whoever is going to be striving to solve for that problem. So it is both smart policy for climate change, but it's also smart policy domestically. So and we should do it. Now, I meant there are more things that need to be done. I mentioned the case of solar and government policies over there earlier on as an example. And Mary sort of mentioned in passing the issue of carbon and carbon externalities, whether we're going to price carbon externalities. So in some sense, indirectly stop subsidizing sort of types of energy production or consumption that are sort of particularly bad for climate. So that's potentially something that we need to introduce to level the playing field. I want to also add something, and I want to almost hypothetically challenge all of the audience. I think the topic of climate should stop being politicized. And the population should be able to get accurate information about the phenomenon. We should all be able to know what are the forecasted paths for the various phenomena of interest. What are their implications in our lives? So we start internalizing what this means for all of us. I bet if we do a poll right now, we have 365 participants right now logged into this event. If we do a poll and we ask ourselves specific questions about what do we think are going to be implications of climate change in 20, 40, 60 years from now, in particular areas, let's say, temperatures, water levels, food supply, etc., we would get sort of broad disagreement in our responses. We don't quite know how to answer these questions. And that's not because we don't have answers to these questions, it's because information is not sort of disseminated well. And these are simple questions, and we need to have simple responses to that, because consumer response will be crucial, both when they go to vote for governments and when they go and buy products. So we need to be able to educate consumers on that. Here's a very simple question. We talk about electrifying cars. Let's all buy electric cars. Let's replace all sort of ground transportation through electric vehicles. And let's imagine we do that in the next 15, 20 years. What does that do to the climate change problem? We should have a coherent response where almost all of us agree to what that means, so that we can all focus on that problem and attack it. But I bet we're going to get 365 slightly different responses with quite a bit of disagreement among them. So I think we need better information, and that's not about the government, that's about institutions like ours. Going back to the climate school could be where sort of things come together and they get amplified and they get leveraged so that they can actually have impact outside in the world. But it can also be a place where we can use it as a beacon of information for the broad population. So I think that's a crucial thing that we need to solve, because you mentioned the previous government, Safwan, and presumably the narrative keeps sort of flip-flopping, and we need to stop that, right?
Yeah, absolutely. Julie?
Yeah, Costis, I guess you brought up the important topic about educating citizens, and there are questions from the audience, and I think just to speak a little bit about, from your perspective, and then maybe Mary, from your perspective, of how we prepare our students or educate them to become leaders in advocating for this change, right? So how are your academic programs changing to address that and to really give voice to the students that graduate from Columbia in terms of being advocates for this and integrating these kinds of data, information, advocacy efforts into the educational programs you're building? And
yeah, so I mentioned at the onset that I believe that addressing problems, strategic questions, and opportunities that arise from climate change is a core priority for the business school. And we've already been doing that, but we need to do a lot more. simply because essentially all of our students, not because they're citizens of the world and they will be affected from climate change, but all of our students now, and certainly in 5, 10, 15, 20 years from now, will be affected from this phenomenon in their own professional career paths. So we're introducing curriculum both to expose students to these issues, to expose students to amazing technological breakthroughs and what are the opportunities that come with that. And I think that's an area that Mary and I should be collaborating more so that we bring our engineering colleagues in our classroom to talk about the engineering breakthroughs rather than us talking to our students about the engineering breakthroughs. And then I believe you're touching on a topic which has to do about what's the role of businesses in society. So, you know, business and economic activity serves really as I like to say, it's one of the organizing forces in modern society. And businesses throughout time, but specifically now, are being asked to take an active role in thinking about societal questions. And, you know, how we deal with climate is one, but, you know, inequality is another, education, race. So business leaders and business schools need to actually be actively engaging in that dialogue. And that's another priority for the school, to create sort of socially responsible leaders that presumably will pursue economic opportunity and transform, have transformative impact to society through whatever they do. But in addition to that, be thinking about some of these questions. And I keep bringing up questions, examples. I'll bring another one. One of our former MBA students, the year after he graduated, he wanted to solve what he called the cattle problem, beef, and the greenhouse gas emissions coming out of that. So he started a company. The company is called Beyond Meat. It's probably the most successful climate company that has come out of Colombia. It's a sort of large, multi-billion-dollar, publicly traded organization. Ethan Brown is an amazing leader that had a vision to exactly go and attack that question. And of course, we need hundreds of these to attack other questions, right? So we need to have socially minded students that are driven, and then they need to go out there and change the world. And we are certainly focusing on that.
So Julie, I would say just to on Costis' last comment on socially minded students, I think Columbia actually attracts socially minded students. I think there's a sense of Columbia that no matter what field, and maybe that's just my sense, but it's almost that no matter what field a student is pursuing, what school they're pursuing their degree, there's a sense of wanting to have an impact, a positive impact on society. So I think we do have this sense of socially minded students, and how can they really make a difference with whatever their talent is and whatever their interest is. So there are different ways that we are currently helping accelerate education programs that are connected to sustainability and climate. Of course, we have specific degrees in earth and environmental engineering that are focused in these areas, but we're also seeing that that students, you know, if you're a mechanical engineer or a chemical engineer or an electrical engineer, that or an operations research student, that you want to have more knowledge about energy and climate. So we're creating concentrations and minors so that they take their electives and can actually build that portfolio to map onto their more disciplinary domain knowledge. So I think we're seeing more and more of that in these kinds of areas. And then how do we connect that again across into other fields? So for example, a new degree that we're launching. It's an MS in carbon management, and this is actually had ties to the Earth Institute, which of course Earth Institute is now part of the climate school. So this sense of that degree programs that connect both the disciplinary domain, which is actually quite interdisciplinary in itself, with say non-traditional partners. Okay, so get some policy in there, get some business in there, together with your engineering knowledge. So we're starting to see those kinds of programs emerge, and also we see the first degree program of the climate school itself is rather interdisciplinary in that nature. So how do we as a university, I think not only at our school level, but more broadly about how we prepare our students for these areas. And that does not take away from, I saw one of the questions about, if a student is, you're an electrical engineer and you really just love the foundational elements of electrical engineering. Well, for example, the research that's been going on for the last 10 to 15 years in photonics, okay, by applied physicists and electrical engineers, it's now silicon photonics, so photonics on a chip. So transmitting energy, not by electrons, but by photons. This has a huge impact now. Now it's ready. As I said before, we like to say we're ready. This is now ready to take our data centers and make them green data centers, right? So we want, those students who have that passion for the very foundational work that we don't know where it's going to go. We find that it then has that impact, right? Just as we were prepared, as globally to create these vaccines, it's because of all the foundational work on messenger RNA and lipid bilayers that then led to us being ready to prepare these vaccines. So I'm just answering one of the questions I saw in the chat box there, that there's many different ways students can be preparing themselves to have that impact. And there's a shorter term aspect and also the longer term.
And I think one of the most important things that both of you have highlighted as far as the students are concerned, and I agree with you, Mary, I mean, Columbia does attract students who are socially responsible, who want to make an impact in the world. And they come from all over the world, which is also a cause for hope, because they learn and they engage, and then they go back and they try to influence things wherever they come from. And I think, what I'm hearing also from the two of you, and inspired by the collaborations that go on between the two schools, is that the way we think about academic disciplines has been changing, has been transforming over the past couple of decades, right? I mean, you can no longer have an impact on a world's problems, such as climate change, looking at it from a narrow disciplinary perspective, right? So what happens in applied science has impact and has intersection with areas that go from public health to psychology to business, obviously, to policy work. So the pandisciplinarity of it all is really incredibly important, and maybe climate change is the way to lead that. I mean, this is the first school that Columbia has started in many, many decades, right? And it is it defies sort of the traditional way that we think of academic structures, in that it really cuts across. Let's turn. We have 4 students who are standing by to ask questions live, and let me, before I turn to them, just throw another question to you that maybe you can integrate in answering. And we have not talked about equity, environmental equity. And Mary, you just mentioned vaccines. And in vaccines, we've also seen the inequity that is taking place. And when you have that kind of inequity, it affects us all, So it's not only a matter of responsibility, if you will, or the haves helping the have-nots, but when the have-nots don't get access to vaccine or are more inequitably, if you will, affected by climate change, it affects us. It affects us all. So maybe it's something you can integrate into some of your answers. Yifan Li, welcome. Yifan is a student at the School of International Public Affairs. He is in Beijing, and he has a question for you. Yifan?
Hi, my name is Yifan. I'm a first-year MPA student from China. I'm currently taking online classes in Beijing. My question is, I'm wondering, what does energy transition and climate change means for developing countries, and how we can use engineering and business to create an inclusive framework to bring developed and developing countries and different stakeholders to work together to maintain our sustainable future. Thank you.
So shall I begin, and then Costis can layer on top? So in engineering, we have been for a number of years now, and this has been highly interdisciplinary, also with policy and business faculty. Together with actually first started with collaboration with the United Nations, had a big effort and continues to have a big effort on decentralized, what we call decentralized energy grids. So how do we help bring energy to developing parts of the world and also rural parts of the US as well, but was really focused on developing parts of the world and creating decentralized grids. Of course, we're bringing engineering solutions to this, but there was a lot of work on the policy and business elements of this work to actually make it sustainable. By sustainable, I mean workable in the long term for the local populations, the smaller towns and villages that were now getting access to energy through these localized solar grids. There's also big efforts analogous to this around water, localized water grids. So there is a big effort there. But at the same time, Yifan, we need to do this at a bigger scale. Yes, by having lots of deploying lots more elements of these decentralized grids. Our Columbia World Projects has focused on these sorts of areas to see how do we map this and scale this in a bigger way. But then we also have countries that are bringing whole scale, large scale power plants to bring their whole population up into a more developed economy, and we need to help there too on not just trying to green our own economy, but and our own energy systems, but how do we also assist in those larger scale, not just the decentralized clean grids, but also larger scale. So this is a complex problem, incredibly important as we work to bring people out of poverty and into a more modern world. So but it's not engineering alone. I can tell you that it's policy, it's business, it's how does all this work together.
Just to add very quickly, I mean, this is clearly the climate problem is a global problem because the carbon sink is shared globally, and the phenomenon is not localized. So we need to very, very aggressively work on solutions, and we need to very aggressively work on solutions in order to allow sort of, I would say, innovation. Government should help, but innovation, corporate innovation, competition, just bring down prices dramatically to the point that they're actually feasible, not just in the US, in Europe, maybe in China, but they're feasible worldwide. So we need to be able to help deploy the solutions globally. And to do that, we need to drive down the cost structure quite a bit. While we're supporting developing countries in their own journey of economic prosperity, right? So, in some sense, we don't want to stifle their own trajectories because we're attacking a problem that they had little to do with. So I think that's crucial. And policy, economics, incentives, finance will be crucial. Engineering solutions will be crucial, but policy at a global level will also be a key element to facilitate that as we move forward.
Thank you. Thank you, Yifan. So we will now turn to Elizabeth Jackson, who is a Columbia College student and is majoring, I think, is pursuing a program with the Earth Institute. Elizabeth, please go ahead with your question. And I know you have to jump to class after this, where you're giving a report. So we're really appreciative of having you.
Thank you, and thank you so much to both of the panelists for participating today. My question is, what do you view, this is directed to both of you, but what do you view as the role of local and international carbon offsets in the transition to net zero? And if you believe that offsets should play a role, how can institutions best verify the quality and additionality of the offsets that they purchase?
Great. Let me take that on first. So I believe that, first of all, in our journey of transitioning to being sort of low carbon and then net zero, we will need to use offsets. At the global level, eventually, we cannot solve the problem with offsets, right? Because the offsets don't balance once you collect everyone together. But some functions will have to be able to offset a little bit their emission by essentially buying offsets from somebody else. You mentioned the additionality, but you also mentioned that the fact that how do we audit whether these are true offsets? And I think this is something that we need to work collectively about, creating a structure, almost like making it a financial security. So when you're buying a ton of carbon sequestration, you know exactly what you're buying, and that this is not something that existed in the past, but this is additive to where we are today. So we need a process that will be able to, in some sense, allow for different solutions, like reduce or remove carbon from the atmosphere to be sort of certified, so that they become almost a tradable security, and then people can trade on that. This is sort of wide open space right now in some ways, and there's lots of work that needs to be done. But I do think that in some ways, offsets will have to be part of the solution, certainly as we start our journey to transitioning to a low carbon or zero carbon state. And we need to sort of facilitate that in a systematic way. Hopefully, in addition to that, we will be able to come up with better prices for all of these things. And that's a slightly different problem, but we can tackle it. I know we're mindful of time, so I stop talking.
So just maybe quickly to layer on top, while I'm not an economics or a policy expert, I agree that offsets will be critical to this as we transition to net zero. But I think we also need to be mindful that the pricing of those and where that really how can that really drive the adaptation of clean systems, clean energy systems, clean everything, that it goes to the right place, right? We talk about electrifying our cars and buildings, but much of that electricity might be coming from coal-fired power plants, right? So we need to put the carbon capture systems on those while we transition those power plants to be clean energy. So there's this a whole. I think maybe the theme of today was the whole complex dynamic of how the engineering solutions, the basic science breakthroughs, the policy, the business, all of these are so interconnected to drive us to this, to a clean future. And we are seeing, by the way, negative carbon, negative emission technologies coming out in materials processing and other areas. So there's a lot of hope, I would say, a lot of hope and a lot of possibility that we can really get there, right? But all of these elements need to be working together in the right way.
So, Safwan, I know you're going to need to close, but I want to echo Mary's positive, optimistic note. I think we need to end on an optimistic note in the following sense. Solutions exist and they're being developed daily, weekly, monthly in breakthroughs in academic labs, in corporate labs. Capital exists and it's abundant to deploy, to sort of implement the solutions at scale. And I think the population is starting to focus on that in a very concentrated and deliberate way. So in some sense, we should be optimistic, but we need to work.
Yeah,
it drives our economic future in an incredibly powerful way. Of course, we need our clean air, our clean water, our clean energy, but getting there will also drive our economic future and pulling everyone up.
So Mary and Costis, if I may impose upon you, because we do have two other students. Elizabeth, thank you. Have a good class. So if we can indulge you to just answer the remaining two questions, that would be great. Julie, would you like to introduce the next student?
Our next student, Mary's a C student. Ozgenur Celik is from Turkey, and also a C student. So she's going to ask our next question.
Good morning, esteemed panelists, guests, and audience. My name is Ozgenur Celik, and I'm a rising senior in the School of Engineering studying biomedical engineering. As an aspiring Columbia engineer, we are taught to engineer for humanity. So how can we, the students, spread awareness individually on climate change within our community across the globe?
So Ozgenur, we were talking about our socially minded students, and here you are one of them for sure. And it's our impact in bringing engineering for humanity. I think Columbia engineers actually should be ambassadors to the world on this. Whether you're working in biomedical engineering and creating the solutions for health and medicine going forward, and also we're seeing biomedical, by the way, has a role in climate, our climate work as well. So I do think our students, and not just our Columbia engineering students, but all of Columbia students can be great ambassadors to really be helping get out the right information about how engineering can really have and drive such a positive impact on human lives around the world. I think the world is understanding that more and more, right? But I also refer to this is a period of an engineering renaissance, because we see engineering impacting every part of society and doing so in such a positive way. And most of the public now understands that as well. So let's get out there and really have that message that this is how we create a better future for everyone around the globe. So thank you.
Thank you.
Great, and we're going to now, Costis, turn over to one of your students, Travis Leiter from the Business School.
Thank you very much. Thank you both for being here today. So my question is, you both discussed integrating various Columbia programs to address climate change. Columbia is specifically working to promote these cross-functional relationships for students and alumni alike across the various schools in order to educate and attract the next generation of environmental leadership.
So let me give a couple of specific examples, but start by saying we need to do more, okay? So maybe some of the programs that we do here at the school, at the business school, that are actually more broadly accessible to students also from elsewhere in the university. There is the 3 Karen's Climate Fellows. So we take students and we connect them and alumni, and we connect them to projects in industry that focus on climate change. And the whole idea is to create this conduit where we connect interested organizations that work in these problems and bring students and alums to actually contribute. Last year, for example, we had 16 such companies do such projects, and we had 50 students that went to work with it. Is that a big number? No. Do we need to do more? Yes. The Tamer Center, as you know, also has a big program on social enterprise that also tries to be more open than just to the business school students, and is an umbrella for things across the university. So again, this is liaising students, funding internships to go to places where we pay the student to go and work in places to do some of that work, which is impactful by itself. But if I step back a little bit, part of the many conversations that Mary and I have been having for many years now, all of the joint programs that we're starting, the joint programs that we're all thinking about starting with the new climate school, the work that we're doing with SIPA, the work that we're trying to do with other schools, the medical school, etc., the law school, is all about bringing people together and collecting and focusing their attention into sort of trying to foster interdisciplinary sort of approach and ultimately solution to these problems. So this is an area that we're trying to do more, and more is needed, but the effort is there and the results are beginning to be there for sure. The second thing that you mentioned is you mentioned the word alumni, and I think it is absolutely crucial to bring into that conversation our alumni. We have, the business school have about 50,000 alums, many of them, as you know, leading change across the world. We want these people to be part of that dialogue. We want them to be included in the conversation. We want us to be able to go and help them, and them to be able to help us, and ultimately to be able to create leverage this amazing network that not just the business school, but the entire university has globally. And we should lean on that, our alumni network, our global alumni network, to actually do things at scale. So I think that's crucial for us. And institutions like ours, similar to governments, but institutions like ours have connections across the world. Right. I mean, sort of global centers and the efforts that Safwan sort of leads. But it's not just that. The faculty, the deans, the scholars across the school, and the fact that we have an international student population really allows us to be a global institution, and we should leverage that to actually be part of that global solution. So this is important, an important role for a place like us to be able to play in that journey.
And just to layer a little bit on top of that, I would see on our Columbia World projects really actually being one vehicle to really bring our alumni connections in more and more concrete ways going forward. I wanted to just add one little thing, is that we do for students, which we have seen to be really to activate students across schools to work together, and that is the Columbia Design Challenges. Right. So the Columbia Design Challenges, while they're, maybe they're launched by engineering, we bring in faculty and external alumni experts on different challenges of the day to educate our students to then go work collectively on potential ideas and solutions. these challenges have attracted students from nearly every school to come together, and then they form teams spontaneously from gathering to listen to the experts, and then put together. There could be an architecture student working with a material scientist and a mechanical engineer, and a business school student and a policy student to create solutions. The most recent one we did was on the problem of microplastics. That was just a couple months ago, and it was led by one of our chemical engineering, or two of our chemical engineering faculty, but they brought in experts from outside and also from different parts of the university to really expose our students to the many dimensionalities of a challenge of that sort, to start the thinking. How do we get our students involved in really thinking about these big challenges, and how they can start to bring their talents to bear on them? So I think there's ways that are curricular, there's ways that are co-curricular, and there are ways that we can help propel startups and engagements with larger scale industry and our global alumni community. So, and I think just a final sort of, if you want to call it a pitch, for our Columbia World Projects, now being led by Professor Wafel Al-Sadr, who leads ICAP, which has brought important solutions to HIV to around the globe, is now leading Columbia World Projects, and how how do we really reach out and engage our larger scale community, and how do we scale our efforts? So I think there's a lot going on at Columbia today that prepares us for a really bold future going forward.
Thank you, Mary. Thank you. I mean, I think that that's a very important point. And Travis, what you're hearing also is that it's not just the faculty and the research, it's not just the students, it's also alumni, and it is about research and curriculum and co-curriculum, and it is about collaboration, with entities and individuals outside of Columbia. No one university can claim to have the ability to come up with any solutions, or with, yes, maybe with a lot of solutions on its own. And that's why I loved you bringing in Columbia World Projects, Mary, because it is all about building those collaborations and those partnerships. Julie, before we close, anything from your end? Anything from the audience that you want to bring up?
Just to acknowledge that we got many questions during this incredible dialogue that we're obviously not going to have time to get to. And I know we want to give you each a moment to say a final comment. And maybe I'll just note that in the comments, there were many questions about both thinking at a community scale and at a global scale. What have we learned coming out of this amazing year in terms of the pandemic that might be applicable here, and maybe using that as a way to close, because I think a lot of people were thinking about what have we learned about global collaboration, and what have we learned about community collaboration from the pandemic that might lend itself to these challenges we face in climate.
Yeah, Judy, I think that that's a great way to end this. So I'll ask you each maybe to just say a couple of closing words and maybe address what Julie has just brought up. Mary, you want to go first?
Sure, I can start. So maybe first saying a few things on how has the last year impacted us all. In many ways. First, I think we found a whole new ways to be connected with one another and to maintain those connections in going forward. In a positive sense, we've been able to be globally connected in ways that we were not pursuing. Maybe they were always there, but we were not pursuing them before. So I think we will see much of that remaining, especially given the amazing global community of Columbia. We also learned how important it is to be ready with the breakthroughs, and to have the ability to really rapidly translate these to real world impact. I think this has inspired so many, and when we look at that the challenge of the pandemic, it also opened our eyes to better recognizing, I would say engineers have recognized for somewhat, but for the world to better recognize the challenge of climate change and also the challenge of social justice. So we have these three just unreal challenges going on at once, and that we as a community, as a university, need to be more actively partaking in and thinking of how our work can bring impact on these challenges facing the world, not just the pandemic, but the climate change, social justice. How do we really focus our efforts, our education, our research, our translation of research to real world impact on these challenges? And I think, as I said earlier, Columbia attracts the student and the faculty and the staff who really are socially minded, committed to having an impact. And so the last year, if anything, while it's been challenging, it's also been has inspired us in what we should be doing going forward.
Thank you, Mary. Costis?
I'll keep my comments brief, and I'll try to make 3 quick observations. The crisis that came upon us about 18 months ago brought all of us closer, and in some sense also brought to the fore new ways, different ways of us being able to collaborate and affect positive impact. So I think that's something that we should try to marshal forward in our efforts, let's say in our own institution, in our government, in our state, etc. It has also brought in new issues, social justice, race, injustice, and that in some sense has refocused the population on crucial issues that we need to be part of that solution and that dialogue. So I think that's important. And that's another important thing that has sort of happened in the last year, and it should not sort of go unnoticed. In terms of international collaboration, I think we've done well, but clearly we realize that we're still a little bit operating in a 2-class system. So while we recognized and we found amazing breakthroughs very quickly to sort of address a global pandemic at that scale, and I think we need to be extremely satisfied by what we managed to achieve in such a short period of time. It does show that these things don't percolate and distribute globally as sort of seamlessly as one would think. So more work is needed in that. And when we think about climate, for example, we would need to be acutely aware of that. But it's not just about climate. The sort of COVID-19 pandemic showed us that, again, parts of the population have almost been fully vaccinated. Other parts of the world don't have access to vaccines right now. And they're thinking about 2022 and 2023 and 2024. And we're sort of counting time in weeks or months. And that is something that we need to be acutely aware. We need to figure out ways to be able to sort of provide solutions at the global scale, which is not easy, but I think we need to be cognizant of that.
So if I can just say, I think to say that in a shorter way is, I know Safwan wants me to stop talking.
No. I mean, I could listen to you forever.
It's really, the last year and these, 3 major challenges that I really focused on the pandemic, climate change, social justice, it has really heightened our understanding of the interconnectedness of our world. We are in a global society, and you know, what happens in one place happens everywhere. You know, it propagates in different ways, and we need to recognize that. And I think at Columbia we recognize that. And how do we, you know, as Ozgenur was saying, how are we going to be the ambassadors of helping make the change and have that impact globally?
Yeah, no, absolutely. I mean, I think one of the ironies of the past 18 months or so is that it underscored how globally interconnected we are, right? I mean, you know, you have a virus that comes out of a corner of China, and within days, weeks, it becomes a global pandemic. But yet, the way that we've had to deal with it is to be physically distanced, you know, to close down borders and to isolate ourselves, right? But then when it came to coming up with the vaccines, with dealing with this, with coming up with the solutions, we collaborated across the world. And I think there's a lot to be learned from that experience, you know, that we are globally interconnected, you know, in for better and for worse sometimes. I think it has been a year where we've all reflected quite a bit about everything in our lives, and perhaps climate being amongst the top things that we have been thinking about, and has enabled us to really plan for a better future. You know, we often say we don't want to go back to life as normal, the way that it was before. We want to create a new normal. And I think what the two of you, Mary and Costis, have helped us understand is what that new normal might look like, and what kinds of things we have to do, what the kind of hard work that we all collectively and individually have to undertake. I loved what you said, Costis, about the fact that we need to stop politicizing climate change, right? I mean, it is something that we all share, regardless of our political leanings, regardless of where we are in the world, and geographically or socioeconomically. We all have a shared responsibility. I've learned so much from listening to the two of you. You know, I've been at Columbia for 32 years, and I am just inspired by the leadership that the two of you bring overall, and particularly around this issue. I've come out of this feeling far more hopeful about the future with climate change. And I think this has just been incredibly inspiring, instructive, insightful. And I know if I feel this way, I'm sure that many, if not all, of our audience members have as well. So I can't thank you enough. And Julie, thank you as always for your great partnership on this series and everything else that we've been doing together. And I think, you know, what keeps us all ticking, what keeps us all alive and excited about the work that we do is our students. So really a special thanks to the students, those who post questions and those who attended, and many, many thanks to other members of our audience, of course. So sorry to keep you longer, but we could go on for yet a lot longer. But thank you. Thank you. Bye.
Thank you, everyone.
Bye.
Bye. Bye.